Good afternoon, everyone. I'm just going to type into the chat just so you can all see it that we have it here. That you're able to submit chats here. So it'd be great to know where you're all coming from and where you're based today. I can see we've got a nice amount of people coming through. Nice. Cold, Listerville. Yes, Simone, it is cold today. Great. Cool. Okay. Well, I should probably introduce myself after doing the chat, but my name is Tom. I'm the Regional Marketing Manager for ANZ, and I'll be the admin for this session. So if you have any problems or anything, please put them in the chat and hopefully I'll be able to help you. But we also have Dione and Sophia from sales on this call. And so if you have any questions around that, please do put them in the chat. We also have a Q&A function as well. So those will be able to go to both Robert and Margaret today. But Robert, if you just go back one slide, I'd just like to take a moment to acknowledge the land that we're on. Where I am is the land of the Wurundjeri. And in the spirit of reconciliation, Cengage Australia acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Cool. Thanks, Robert. So on to my housekeeping elements. And as I said, it's great to see you in the chat saying hello. So please keep it coming. If you have any questions there for both Margaret and Robert during this session, you can type in there. There's also a Q&A function, which you're more than welcome to use as well. We're going to try and answer as many questions as we can during the webinar, but if we don't get to any, get to all of them rather, you will receive an email next week that will have the PowerPoint slides as well as the recording for today as well. So if there's any questions we don't get to there, we can always put it in there as well. And on to the next slide, please, Robert. And here's just a few details of everyone. As I mentioned, we have Sophia and Dione joining us today. They'll be in the chat answering any questions, as well as we have Nicole, your digital success manager, and Nelson Mindtap trainer. Without further ado, I'll hand over to Margaret and Robert.
Okay. Hi, everyone. Margaret, would you like to tell us about what's changed in the Maths Advanced and Extensions syllabus?
Yeah. Thanks, Robert. There will be a little bit of overlap and a little bit of repetition as we go through, because we'll start off with just a summary of what's changing and then we'll go into more detail later. So you might see things 2 or 3 times. Don't worry about trying to take notes, because you will have the access to these PowerPoint slides later. The good news is that not a huge amount has changed in the courses, although there are some specific things that you need to keep an eye out for. It's been more streamlined, and there have been some things that were put back that were in the pre-2019 syllabus. Also some swaps between the 3 different advanced and extension courses. For example, transformations of functions is now in year 11. It was in year 12. The other thing that's happened is the common content's gone between advanced and standard 2. Now the reference sheets, we will start with those. Robert, if you'd like to change the slide, because that gives us a bit of an idea of what's in the course. So nothing much has changed. I'll start with the advanced one, and the first page, there's nothing really to talk about. The second page, the main thing there is that in sequences and series, no content has changed, but just the notation. So instead of TN, we've got AN. Also, for the geometric progressions, there's only one formula for the sum instead of the 2, and they've chosen the one that naturally guides you into the infinite sum or the limiting sum. The other thing that's changed in sequences and series is that the summation or sigma notation has returned from the previous courses. The new work in the advanced is in the continuous random variables, which is in year 12. And we've got the expected value and the variance there. And if you've got an ordinary distribution that's a quadratic or a cubic or something, it's quite easy. We just do an integral instead of a sum. We have f of x for the expected value, and we have an x squared in the variance. So it can make for tricky integration, which we'll see an example of later. But basically, they're pretty straightforward, and they're in the reference sheets. The next one is just a quick look at the sample HSC. Most of the sample HSC exam is from old past papers, but there are some new things. So for example, in the summation notation that I just mentioned, there's a question there. Also in year 11, there's the variation with powers of x rather than just x itself. So there's a little question on the paper on that. If you're already teaching the year 11, you will be familiar with these year 11 changes anyway, but we wanted to make sure we covered both year 11 and 12. Okay, the next one is the new expected value for the continuous random variables. And you can see that this creates quite a tricky integral that you normally wouldn't be able to do. So you can use what's given there to find the expected value. And for part C, all you have to do there is that show that the integral from 0 up to 0.25 is actually larger than the median, which is 0.5. So you just integrate up to the expected value and you should get a result that's larger than 0.5 or the median.
Yeah, and we'll actually do an example like that in later in this presentation.
Yeah.
Okay, now let's have a look at Math Standard 1 and 2. So I'm going to treat them together because there's quite a lot of overlap between them. So basically in the new syllabus, there's decluttering and streamlining of content. I feel like the new courses are a little simpler than before because we've got things like ratios and rates and Pythagoras' theorem, which is really stage 4. So it's decluttering, more focus on deeper learning. Part of networks has been moved to year 11, and we no longer have to share common content and the HSC exam questions with Maths Advanced, so that frees up a few things. So if you look at the reference sheet, no real surprises there. The only difference is that the longitudinal difference and the time difference, that 15 degrees equals 1 hour time difference is there, as well as the metric conversions between volume and capacity. So that's the only thing that's changed there. And if you look at some of the new questions in the HSC exam, we've got something, this is for Math Standard 1. So this is budgeting and looking at something called an emergency fund account. So the maths isn't really that hard. It's just the new concepts, new financial maths involved here. And then we've got here a question on correlation versus causality, which used to be in the course, and then it wasn't, and now it's back in. So there's a explicit question here worth 2 marks on interpreting the correlation between amount of exercise and physical health. And then we look at Math Standard 2. If you look at this, it looks, can you see what's different? How this is different to the old syllabus or the current syllabus? It's basically a simultaneous equations problem where you have to set up the equation. But what's back in the syllabus now is that the algebraic solution of simultaneous equations. So that's back in Math Standard 2. And then we've got things like buy now, pay later payment scheme. So this is some new financial maths going on here. Again, it's not, the maths behind it's not hard, but just a lot of reading and interpretation of the financial terms and conditions. And then Venn diagrams are new to Maths Standard 2 course. So we already teach it in Maths Advanced. We already teach it in Stage 5, but now it's now being integrated into Maths Standard 2. And then, okay, so then we have a look at Maths Extension 1. So back to Magaret, who's going to show you what's new on the reference sheet there.
Yes, the only real change is that the projection of vectors has gone onto the reference sheet. The notation for vectors is now bold when it's in print, but of course you can't get students to put bold in their handwritten stuff. So we've got, if you have a look on the right side, the tilde underneath each of the vectors is the way that you can write them. Also the AB with the arrow on top is another acceptable one. You can't see it there, but vectors in 3 dimensions are also now in Maths Extension 1. And the formulas are a little bit different, but really just an extension. So for example, the magnitude of u is just the square root of x squared plus y squared plus z squared. So that's really the only change there. If you have a look at the sample HSC, then you might recognize this if you've been teaching for a while, back to the old binomial theorem questions. So that's now back in. That's in year 11. This is a year 12 one, which is on the standard distribution of the means. So, sorry, sample distribution of means. And the central limit theorem. It's not all that difficult. It's just a matter of getting your head around it. And that's really, there's not a lot of new work there. So this is the random, using the standard normal distribution to find probabilities. So if the sample is more than 30, or I should say 30 or more, then it resembles a normal distribution. So you can use all the normal distribution work on those.
Okay, well, let's have a look at how we're implementing these changes to the syllabus.
Okay.
Yeah, we're going to go through each of the books. So we publish for every course, but we'll start with the Year 11 Mathematics Advanced and have a look at what's different there, Magaret.
Yep, sure. So you might notice that discrete probability distributions are not there because they've gone to year 12. Transformation of functions have come back from year 12 to year 11. So there's just a direct swap there. Probability also includes some data because now we don't have full statistics in the course, but the data is setting you up for the year 12 probability distributions, the discrete and continuous distributions. So things like statistics, histograms and tables and so on, and random variables, and the notation associated with that. Just some little things too. In trigonometry, the 3-dimensional applications have gone back to extension 1. I mentioned before about variation and the transformations. Now, with the transformations, the methodology's changed. It's a little bit more explicit, so we don't have to just take on faith that if it's x plus a, then you're moving to the left and so on. So if you have a look at the next one, it gives you a little bit more detail about that. So for example, if you're doing a horizontal dilation, you replace y with y over, sorry, a vertical dilation. Replace y with y over L, and then the L comes to the other side. If you look at a horizontal translation, we've got x minus a, and if a happens to be, say, -3, then you end up with x plus a. So it explains the opposite signs quite well, really. And if you go to the next slide, I'm sorry, I'm going through this really quickly. because we don't have much time. But if you have a look there, you've got 4 things happening there to the function y equals g of x. So the vertical dilation, replace y with y over 5, and then you can bring the 5 to the other side. Reflections in the y-axis, you're putting a minus in front of the x. Translating down, we are going to replace, 4 units to the right, I skipped one. We replace the x with x minus 4, and then translation 9 units down, we change to y minus 9. So it's, if you've been teaching it a different way, it's a little while to get your head around, but it actually works out more easily, I think. And just generally, if it's a vertical dilation, it's affecting y values, and it's a horizontal transformation, it's going to affect x values.
So we still teach the old formula as well, the old way, but this is another way, and I guess these 2 methods complement each other.
Yeah, this is a good introduction of how they come about, and then you can start thinking about formulas. You know, you don't want to do it from first principles all the time once you know what you're doing.
Okay. And okay, so this is the transformations of functions chapter in the year 11 book. So we're just showing you what the front of our chapters look like. So we've got an introduction to the chapter, and then we've got a chapter outline with the syllabus codes all there. And then we've got the chapter dot point objectives. And then we've got the Nelson MindTap, which is our digital platform with all the resources. And in this chapter, there's some videos and worksheets that go with it. And then we've got terminology as well, a list of keywords that will be covered in this chapter, because we've got a big focus in this series on mathematical literacy and terminology. And then I'll let you talk about this one, Margaret, because I think you...
Okay.
Yeah.
My books have always been graded from easier to harder, but this one just sets it out a little bit more easily. So you can see the green are the foundation ones, blues mastery, and then complex is red. So it just gives a color coding to those gradings. So if people want to concentrate on the easy things, they can go straight to there. If they're finding those too easy, they can go straight to the harder questions. So it's just a nice visual way of showing those.
Okay, and what about this next one? What's this
right.
showing?
At the end of each chapter, we've got a sample HSC problem, but there are also typical HSC style questions in each exercise as well. But this just reminds you that these are the sorts of things that can go into the HSC exams. So we have one of those at the end of the chapter.
Oh, and do you have these in the exercises as well?
Yes.
Yeah.
Yes.
Okay. And then when we get
tried to incorporate as many HSC style questions as I can in the exercises.
Yeah. So I mean, yeah. So in every book, including the math standard books, the authors have studied the past how many years has it been? Six years worth of HSC exams. So then we've been trying to include, we write in the same style as the HSC exam. And then when we get to the end of a chapter, we've got this chapter summary, and we've done something different with this edition. Yeah, so what we've done is we've listed the chapter objectives again, and then we've written and we've mapped it to the section that it's covered. And then we've asked students to do a mind map summary of the topic. So we've given them the topics, given them the template to make the chapter summary. And then we've got the usual things as well, like we've got the chapter review exercise called Test Yourself. Okay, so we're still moving on to the Year 11 Maths Advance and things that have changed. So Margaret?
Yes, so I've mentioned before the discrete random variables have changed. What I haven't mentioned is with probability, there's a lot more set notation in there. And as I mentioned, relative frequencies, histograms, etc., which are precursors to the random variables.
Okay, so now we've got the Year 12 Maths Advanced table of
Yeah.
contents. So how is this different to what we had
Okay,
before?
so as you can see, transformations have gone out of that back to Year 11, and statistics in correlation and regression have been removed altogether. And the discrete probability distributions have come in from Year 11. The applications of calculus we also now have back in advanced, the exponential growth and decay, plus rates of change, motion of a particle, and all those things are in that application chapter. Apart from that, I think everything probably looks very similar to what it was before.
Yeah, and like you said before, similar to the previous syllabus, things are slotting back into what they used to be.
Yeah.
Okay, so now we're at Year 12 Maths Advanced and some of the changes here.
Yes. So I've mentioned some of these, so I'll go quickly through it. The thing that has been moved to extension 1 is the areas between two different curves. Extension 1 already had volumes from a move from the previous course, so that's extension 1 now. So advanced students only need to do areas between X and Y axis and a single curve. I've mentioned the notation for the sequences. I've mentioned exponential growth and decay and the new expected value and variance. What I haven't mentioned is also we're doing derivatives of sec, cosec, and cot, which is totally new. So that's just a new section in the trig chapter there.
So here's an example of expected value of a continuous random variable.
Yes.
So how is this different to what we've done before?
Okay, so this is what that sample exam one, if you remember, was more complex than this. This is a more straightforward one in that if you're looking at the expected value, you just do x, f of x. So you have an x in front of the f of x, which means instead of 6 plus 5x minus x squared, we've got 6x plus 5x squared minus x cubed. So it's just a straightforward integral. When you solve that and you get 2.125 for the mean or the expected value, you then in part B have to show that the median is greater than that. And the way to do that is to find that the area, compare the area of the expected value with the area for the median. You don't have to actually calculate the median because we know that the median is just going to be the integral will equal 0.5. So if you work out what the area is between 0 and the 2.125, which is the expected value, that comes in at just under 5. So that means the expected value is a little bit less than the median.
Yep, okay. All right. We've got a question in the chat for you, Margaret. How much have the exercise questions changed from the old textbooks, from the previous edition, in Advanced and Extension 1?
I've added in more complex questions to most exercises, not all, but I've tried to add in harder questions and HSC type questions. As you saw in that example before, there are exercises on the exponential growth and decay that have come from previous course. There are questions on the variance and expected value for continuous distributions along the lines of that HSC course exams. Yeah, all the sample HSC exams. I've gone through the sample and I've also gone through the last however many years, 6 years or whatever, of exams, and I've actually upgraded the exercises to include fairly typical ones that have been in past HSC exams. So you'll find that there are more challenging exercises there.
Yep, and at the end of each chapter, we also have a challenge exercise as well.
Yeah.
I know that paid proofs are available now for teachers to look at if they wish. And if you compare it to the current edition, you will see that the exercises are much, much longer than what they were before. And now that with our 3-color coding system, you can tell that there is a big range of foundation questions, and then like the typical standard questions, as well as the challenging questions as well. So it's definitely, it's not just a fresh coat of paint, but it's actually quite a bigger, longer book.
Yeah, as the HSC has changed and become a little bit more complex, I'm trying to reflect that in my examples and exercises in the book as well. Obviously, I can't put absolutely everything in because Cengage would sack me because it would be far too long. But I've tried to put a good selection of those types of questions into the exercises.
Yeah, and I guess it's good to mention too that students are not expected to do every question in every exercise. We've just provided a lot more choice for teachers and students to decide which questions to go for. So yeah, we've made it very appropriate for a wide level of abilities. Okay, let's have a look at Maths Standard now. So Year 11 Maths Standard, we actually provide two, even though it's the same course, we provide 2 pathways. So we provide one for students who are going on to Standard 2 and the exam, and one book for students who are definitely going on to pathway to Standard 1 and possibly doing the exam. So if you look there, we've got chapters 1 to 14 for Year 11 Standard Pathway 1. So interesting figures is like simple and compound interest, but that's been moved to Year 12. So has the Taking Chances, chapter 6, gone to Year 12, probability. Healthy figures has been replaced by safe driving. And then finding the right path is a networks topic, the only networks topic for Maths Standard 1. So that's been moved out of Year 12 and into Year 11. And then the Year 11 Maths Standard Pathway 2, pretty much the same thing. Okay, you can see there. So networks has come in and probability has gone to Year 12. And if you look at the changes, what's been removed is measurement error, because that's done in stage 5 now. Energy in food and electricity, the Pareto charts, deciles, quartiles, and sample standard deviation. What's new is the buy now, pay later schemes, as well as term payments, infographics, line graphs, and so on. So a lot more financial maths. I think buy now, pay later has been introduced because that's a new thing. It's like an interest-free loan, but where you can buy things. It's similar to lay-by, I guess, but it's but you have to pay a fee, and you also have to pay a late fee if you don't pay on time. So there's admin fees rather than interest. As I said before, this half of the networks chapter or topic from Year 12 has moved into Year 11. And then with Year 12 Standard 1, what have we got here? So finding the right path, that networks topic has gone to Year 11. Healthy heart, there isn't, all the heartbeat and blood pressure stuff has now been taken out. It's been replaced by Taking Chances, the probability chapter. And then in Maths Standard 2, more focus on ratios and rates. So we've split the ratios and rates chapter into 2. Chapter 2, ratios and scales, and chapter 9, rates and energy. Okay, and now networks is just focusing on project and flow networks. So in Year 12 Maths Standard, so like I said before, similar target heart rates and blood pressure has been taken out of Standard 1. Capture recapture technique is now more explicit for Standard 2. We've got the short and long-term loans, distant time graphs, and solving simultaneous linear equations algebraically, all for Standard 2. So what's new to networks? Okay, there's a new method. We actually currently teach this in our current editions, the flow capacity by saturated edges method. And I'm going to show you an example in a minute. yeah, we've always taught this method, but now it's explicitly mentioned in the syllabus. We've got dummy activities. Again, we've always taught it in our books, but it wasn't explicitly mentioned, but now it is. And also the Gantt charts there. So saturation method looks like this. Okay, so this is a network of road traffic in a city from the source to the sink. And we want to determine the maximum flow possible from the source to the sink. Now, originally, conventionally, we would use the maximum flow minimum cut method, but now we have this other method. But if you already teach from our textbooks, that you would already know this method, where we go through and try to exhaust all the different routes that we can go through to maximize the flow. So notice that at the source there, we've got a maximum output of 880 cars per hour, I think it is. And that's by adding these three. And then at the sink at T, we've got a maximum, inflow of 850. Now that tells me that the maximum flow for this network has to be less than 850 because it's a smaller value. So what we do to do this is we have to try out every single route or every single part along the roads. So let's choose this one. And I can see that this bottom one, I can take out 250. I can reduce it by 250. So if I do that, this is, if I subtract 250 from every road, these are the figures that I get. Okay, so I'll also write 250 there to let me know that this is what I've got to add up. Okay, I am going to go pretty fast on this, but you will have access to these slides, so you can go through this in a bit more detail. But we're also recording this so you can watch the video back. So my next route there is going to go through there, right? And I can take out 150 from each of those roads and exhaust that by 150. And you'll notice then I've got some of those roads now have 0 next to them, which means I can't use them anymore. So I'm choosing routes strategically to reduce the capacity of the roads as much as possible. Now, the next route I'm going to take is this one, because I can take 200 from each one. Okay, so if I do that, subtract 200 from each one, I get this, and you'll notice AT there gets reduced to 0. And I'm also listing them on the left. I'm keeping a tally of what I'm reducing each route by. Okay, now I'm going to go along this road or this route where I can reduce 180, I think it is, from each road, and I put up add that to the tally, and I'm starting to utilize a lot of those roads now. So I've got a lot of zeros, which doesn't give me much choice what else I can do. So I'm going to do this one next, and that is I think I can only take out 20 from each of those roads because 20 is the minimum, the minimum value there. And if I do that, then I get this. And I probably can't go any more, I don't think. Let me see. No, I can't use up any of the routes now because they're all there's a lot of all the routes now have a 0 on at least one of those roads. So there's no capacity left. So I now add up each of these numbers, and that'll give me the maximum flow. So it's 800 cars. And you'll notice what I said before, it's got to be less than 850, and so it is. So if you look at the source there that had a maximum output of 880, you'll notice I haven't used 80, and 880 minus 80 is 800. So that's all those numbers that are left over are the unused capacity of each of those roads. And if you look at 850, well, actually, I'll just go on. Next, part B says to redraw the network, showing the traffic flow along each road in order to achieve the maximum flow. So what I do is I look at my diagram with all the crossed out things. Okay, I might be able to show you with this arrow here. So you'll notice here, I've used up the whole capacity of this road. So that means the maximum flow will be 180 here. But if I look along here, I've got unused capacity of 80. So the amount, the maximum flow through SB will be 300 minus 80. So that's how I get 220. So this diagram at the bottom here gives me the maximum flow, how the maximum flow feeds through. And you'll notice that if I pick any vertex like this one, the flow going in has to match the flow going out, okay? So 180 plus 20 plus 150 gives me 350. So I have just given you a real crash course in how to do saturation method. As I said, some of you already teach this, but now it'll be definitely tested. So you start to exhaust all the routes from the source to the sink to find the maximum flow. Yep. And it's important you don't choose routes in a random order. It's got to be systematic. You don't start with a middle route because you might end up creating dead ends where you can't reach edges with excess flow capacities. So yeah, you just have to go through and try to exhaust as many roads as possible. This is a Gantt chart. So this is a question on the Gantt chart. So this is we've got this activity table here, and you're meant to draw a network diagram for it and then display the data in that Gantt chart. This is what it looks like. So we already know how to teach part A, but part B is just the Gantt chart it's not anything controversial. It's just showing the tasks, the activities as like swimming lanes, and you see how they overlap or how they join into each other. And the ones that have a blank, that's the float times. Okay, so year 12 math standard. What's been removed from standard 2 are the Z-score tables. What's new for standard 1 are the tree diagrams with replacement only. And what's new for standard 2 is the product rule, Venn diagrams, and two-way tables. So what we teach in advanced, we also teach in math. We also teach in standard 2 now. Okay. Yeah, I'm just conscious of time now, but have a look at Maths Extension 1. Okay, I'll get you, Margaret, just to briefly explain how things are different in Extension 1 now.
Yes, I've already mentioned some of these in the quick summary at the beginning. The first thing is that the binomial theorem is back in the course now after several years of being out. And as in the other ones are advanced changes. You notice also that Extension 1 chapters are very clearly labelled.
Yeah, and the Extension 1 books follow the same order and structure as the advanced books, and then the Extension 1 content just slots in there.
Yeah.
Okay,
so the pigeonhole principle and those harder graphs have been removed. A few things have been moved to year 12. That's the multiple zeros of polynomial and inverse trig functions. The T formulas and products to sums in trig have gone to extension 2. And the auxiliary angle methods have gone back to year 11 from year 12. So a little bit of juggling around there with the trig. And I've mentioned the binomial theorem.
Okay, let's have a look at year 12, Maths Extension 1, a lot more Extension 1 topics there.
Yes, so vectors are probably an expansion of what was there. Everything else is pretty much as I've explained previously. So if we can go on to the next slide. Yeah, as I said, the Extension 1 topics, outlines, sections are all pretty clearly marked. And if there's an exercise with both advanced and Extension 1 questions in it, you can see pretty easily which ones are the Extension 1s. They're all related back to the syllabus reference grid, so you can see how each chapter and each topic fits in there. And the next one is, yeah, the year 12. The 3D vectors have been introduced there. Vector proofs in geometry and force vectors are no longer in extension 1. They've moved to extension 2. The projection formulas are now in the reference sheet, which makes it easier. The path of a projectile has also come back from extension 2. And there's a little bit of work on the motion and vectors, a little bit more than is currently in there. Return from year 11 to 12 is inverse trig functions, related rates of change, chain rule, Newton's law of cooling, multiple zeros, etc. We've also got investigations and technological things for students to explore as well, particularly in some of the new topics. And you'll notice there that we're calling them slope fields now rather than direction fields. And there's a lot more work on slope fields in the course. So I've actually dedicated the whole first exercise in that chapter on differential equations to slope fields. So there's a little bit more geometrical work on those. You'll notice that's different. Again, sample HSC problems, you'll probably notice that that's a fairly common question in HSC. You might have seen that before. And derivatives involving parametric equations is new, as is derivatives of inverse functions. And I've mentioned the sampling distribution of the mean, which has replaced the sample proportions. With the derivatives involving parametric equations, it gives a nice flow on into vectors and motion. So things like if you're given displacement as a vector with t as the parameter, then you can just use calculus to find the velocity and acceleration and then back the other way by using integration. So it's a little bit more there, but it's not particularly hard. It's just using calculus to do those things.
Okay, here's that question again.
Sorry, what was that?
Oh, here's that question again, HSC question on the sample mean.
Yes, that's already, I think we've done that before, so I won't worry about that, seeing that we're short on time.
Okay, Maths Extension 2, I've only got time to show you the table of contents, which hasn't changed much from the previous edition, but we're covering the course in 7 chapters there. There's subtle changes within the topic and within the syllabus. Okay, we've also got Nelson Mindtap, as I said before, is our digital platform of resources. So you've got an ebook and you've also got PDF chapters as well. You've got many videos, you've got over 100 worksheets. And for teachers, we also provide topic tests, teaching programs, work solutions to all exercises with explanations and test banks. So our work solutions look like this. They look like worked examples, actually. And so they provide an explanation as well as student working. So we're publishing for all courses. So that's, 9 books in total, covering years 11 and 12. We've got a new page design. It's very attractive, and that's informed by learning research. And we've also got A4 size pages and more HSC style questions. Okay, I'm going to hand over to Sophia now, who's going to give you some information about pricing and availability.
Wonderful. Thank you so much, Robert, and Margaret too. Just to let you know, Robert, there are some questions in the chat as well.
Okay.
I'll just quickly go through this. You can read that yourself. The pricing for each book, when the availability of page proofs and when the books will be published. They're all listed there. Just to let you know, we can do demonstrations on the Nelson Mindtap, the online teacher resources. If you'd like to reach out to myself or Dion, we can sort of arrange a meeting there. Also, Nelson Mindtap online teaching resources are only available with a class set purchase, or if the books are put on the book list. So please reach out to us if you want any further information about that, if you want to get the page proof links. Teaching programs aren't quite ready yet, but we're trying to keep you updated with everything as it comes to hand. Thank you very much.
Okay, and finally, if you want access to this PowerPoint, you just jot this down or take a photo of it, tinyurl.com/mathsinfocus. So you can get a copy there. If you've got more questions for us, then you can write to me. There's my email address there. If you want to find out more, go to our website. Magaret and I will be presenting this on the same this same webinar, but at the Mansfield conference, and we'll have 1 full hour to talk about this in more detail and also to answer your questions. So if you're going to the Mansfield conference, which is at Lura Fairmont Resort this year, hope to see you there. Hope you can come up. Okay, I didn't realize there were questions in the chat, but so I'm just quickly going through them. Has dummy activities been removed? No, it's been explicitly put in. So it was not mentioned in the syllabus. Now it is. Okay. Other textbook publishers sometimes assign which questions students should do based on their ability, such as building versus progressing. Yeah, okay. So we want to leave that to the teacher to do. Like we don't want to be so explicit in saying, oh, these types of students need to do questions 4, 6, 12, whatever. And I do appreciate there are teachers who are out of field or new to teaching. So the best thing that we can do is just to provide those 3 colors showing these are foundation questions. These are, I can't remember what the blue questions, and these are the extension questions. Magaret, do you have anything to add to that?
No, just I hope we've given you enough information to reassure you that apart from a bit of juggling around, the course doesn't have too many new things in it. And yeah, good luck programming your classes. And if you've got any questions, just let us know.
Yeah, I guess the other thing about us, we're grading the questions, but the grading is just so subjective sometimes. It differs from school to school, differs from class to class, student to student. Yeah. So we don't want to tell the teacher which questions to allocate. It really is within the teacher's domain to make those kinds of pedagogical decisions.
Yeah.
So we provided as much help and support as possible. I guess I haven't said it this much today, but we really do stick to the syllabus and stick to the past HSC exams. We try not to make things hard for the teacher to have to decide what content to teach. You basically have to teach everything in our books. Like if it's not in the syllabus, we will explicitly say that. Yeah. Okay. I wonder if there's any more questions. If you have any more, just type it into the chat or the or the Q&A, but I don't think there's anything else. But anyway, thanks for listening to us today. And yeah, please reach out to me or to Sophia or to Dion if you have any more questions, because we're here to help. So thanks for joining us today. Tom, do you want to wrap up for us?
I was just going to say thank you, and expect recording in your inbox next week, guys. Enjoy the rest of your week.
Okay, thanks. Bye.
Bye.
Bye.